because we don't want the session to be very.
Oh, set another 8
Yeah, for us.
Okay, good morning everybody. First, on behalf of my team, I'd like to thank you very much for coming, taking your time to join us here today. Let's move straight to our project. Our project is called EMED, the Future of Medical Protocol. I would like to invite my friend Zoha to talk more about it.
Alright, this is our groups.
Oh.
Alright, then for EMED architecture, which is a good level of help, which is we provide EMED microchip and smartwatch for the medical issue. And then for the needs in this project description is difficulties in reaching the hospital at faster rate, and then the patient that needs to take a long time to get to the hospital and difficult to contact the relative and hospital, then spend more time to find patient's location. When someone that have, which is someone that live alone in the house, they when have emergency case, anybody do not know how is the condition of this patient. So from this smartwatch, it can send the notifications to the hospital, which is the emergency department, to send help, which is we can send the ambulance to the patients. Then this is example of the EMED smartwatch and microchips that will be installed in the patient's body, or everyone that maybe needs to this smartwatch for their daily life. And then this project description, benefit from this project, you can track the multi-health condition of user 24/7 and minimize the response time to respond emergency case by the hospital, eliminate the need of third person to inform the hospital about the emergency of patient, send location of the patient, and help to identify the patient ID and his or her medical history in case of unconscious of patients.
Okay, moving to the architecture significant requirements, I would like to invite Nipon to tell us more about it.
Okay, this is the architecture's requirement for our specific system. So we focus on some quality attributes. So according to those quality attributes, there is quality attribute refinement, and based on those refinement, what our system is providing for as ASI. So like performance, there is transaction response time and throughput. For transaction response time, it's like it's actually during the peak load time, its response. Any transaction of the system can finish within the 5 seconds, and also the during peak load it can transition 100 transaction within the below than 5 seconds. And also the usability, proficiency training and normal operation of the by providing proficiency training of normal operation to the user, any user can easily understand. Any user can easily know about the system within a less than 1 hour training, or just by reading the user manual, which will be give with the smartwatch and the system, and configure the for configurability. We use the attribute refinement for customizability. The system able to extend or customize on existing functionality based on user need, and the feature development within 2 hours to make and test the changes, and no side effect will occur in the system behavior. For this quality attribute, this is the ASI for our system. And also the maintainability is for maintainability. There is a lot of routine changes for the future. The system is able to easier to be maintained, so that program can easier adapt to the changes and perform bug fixing in future, not more than 3% day effort. And also the upgrade to new commercial component. Yeah, maybe new database vendor is coming, new cloud service is coming. So for that, it's just need only 3% day effort to upgrade a new commercial component. And extensibility, adding a new function is very easy to. The system is module separated and is developed using component-based development. So that's why it's produced the high question and low less coupling program. So it's very easy to extensible. security confidential is because we're using the some data from the user. It's medical data or personal data. So it should be quality attribute security is more important for this case. So we provide confidentiality and authenticity. The confidentiality is provided by the user with use defined user typing database. Just like for a user is just like patient user, and also the hospital emergency unit, and also the patient relative and doctor and nurses will get the smartwatch for this on this system. So they will have the defined type of user defined, and the system is authorized is other user privilege in access to some of the feature and data. They only can access what they are able to access on the system, and also authenticity. The system will provide defined ID by providing microchip use, and it is unique for everybody. It's like when they want to use our system, when a user want to use our system, they will get the microchip on their thumb, so they will get unique identification of their microchip. And ability there is no doubt. It's because it's a health-based, so health-based app in the smart city system. So the system is operational and available for 24/7. It's more important for success of the system, and this provide this availability, and with overall availability of 0.98. This is the architecture design of conceptual diagram. So how the system is work. Actually, the patient for patient side, for patient or user, we call it user first, and then when they face any emergency, they need to be patient. So they have a smart chip between their index and thumb finger. Then they have a smartwatch. It will connect smartwatch. The microchip is connect smartwatch by NFC, near field communication. Then the smartwatch. As we talk about, we are in a smart city. So we talk about the smart city means smart city. We just think that smart city already have Wi-Fi in all the place. So first, we just consider that smart city as a Wi-Fi all the place. So the smartwatch is using Wi-Fi to connect to the cloud server. We're using the cloud server for that. So when any emergency happens, the microchip send notification to the smartwatch, and smartwatch send notification to the cloud server, and via the cloud server and hospital emergency will get those emergency things with the GPS location of the patient, and then hospital emergency unit can send notification to the ambulance driver with the GPS location of the patient to bring the patient in the hospital. And after they bring the hospital, and between them, the hospital emergency unit can send the notification to the doctor nurses to give the idea about the real-time location of the user. So they can be already prepared for the patient, and also they can send the notification about the patient. If the patient is unconscious, so they can, maybe nobody in the house, so nobody don't know, their relative don't know what is happened. So the hospital emergency unit can send the notification about the emergency cases to the relatives. And actually for this system, we usually call it user is user first. After they have any emergency, they patient. So also there is 3 different type of smartwatch for doctor, nurse, and the relatives. Those functionalities different.
Okay, and just extra information for the alarm that we get from the patient's watch. It's either automatic or manual. So in case of the patient is conscious, then he can press the alarm button like manually. Otherwise, if he's unconscious, then the alarm will be sent automatically to the cloud server. Thank you very much, Nippon. Moving, development diagram. So now
I am talking about the development diagram of unit. As we do have 2 devices for user side, is like microchip and also the smartwatch. Actually, microchip is communicate with the smartwatch using the NFC, near field communication. And smartwatch is there is functionality in their smartwatch is there is an interface. User can send a notification, and they can receive notification. Receive notification is for the doctor side and nurse side. They can receive the notification, and then and it will connect to the cloud server. Cloud server using the Wi-Fi router. As I talked previously that we are in the smart city, so there is Wi-Fi on the whole over the city. Then the cloud server we using the load balancing inside that there is a operation in the cloud server is load balancing and cloud setup and server operating system in the in the cloud server. Then for the feature for safety, it will connect the database to the database server using the TCP/IP. In that we using the database server of Oracle 10G.
Thank you very much, Nipon. Let's dive deeper for the project, the design. I'll talk about the use case diagram. So here we have technically 4 actors, but matter of fact, since the patient has a smartwatch as well as a microchip, so there are 5 actors. So for the microchip case, the microchip basically can store personal identification, medical records, including measure the blood sugar and then cholesterol level, since it's inside the hand, implanted inside the hand, so it's in touch with the user's blood. That's how we can measure. On the other hand, the smartwatch basically can send notification, send GPS location, as well as displaying blood sugar and cholesterol after getting the information or the results from the microchip, since the microchip is responsible for that because it's inserted inside the human body. Smartwatch can also display, monitor body temperature, monitor heartbeat rate, as well as blood pressure, and that can be done by sensors implanted inside the smartwatch to do these jobs. On the other side, when it's a case of emergency, basically when the smartwatch sends a notification and the GPS, there are 3 types of people that can get the notification and get a GPS location. Those are the nurses, doctors, ambulance drivers, and relatives. For the doctors, the view medical records, they can also update medical records, view personal identification as well from these clouds. Moving to the component here is like also deep concept about the projects here. We have microchip and smartwatch.
We stop.
Alright.
Wait, do you have anything to demo?
Yes, we have prepared like a video.
Doctor, the deployment diagram suddenly pop up before the class diagram.
It doesn't matter. Where's your demo? Something, is it the mockups?
Yeah, that's
Therefore, component microchip, smartwatch, hub, and also cloud server, and the interaction between them. The microchip will be implemented into plans. And the interaction between them is interesting. And the other component are smartwatch. The smartwatch has sensor, manual sensor, and then smartwatch we interact with the hub using Wi-Fi. This interaction between the hub, and then hub we interact with the cloud server. And then cloud server will send notification to HCU, hospital, and cancer unit. That's all about the system.
I think that's pretty much it. Want to add something about the future of like what we're planning to do is basically we want to create make the smartwatch look like a Siri. So in case of emergencies, like you're on a motorcycle or something, you just ask like hey Emet, like I got injured like motorcycle, my elbows is injured, what should I do? So it's gonna give you an immediate like first aid like details, information, so you can take care of yourself in this kind of cases. So that's pretty much everything from us. Thank you very much for listening.
Open back yourself. It's all open to Q&A.
Sorry, what is it again?
Just open back yourself. You open to the Q&A.
You go to the ASR patient. When you talk about customizability, what do you mean by customizability? What can you customize for?
For the future, just Ali said about the future, maybe there will be a little bit the functionality customized this technology.
Yeah, so in this case, for example, the functionality of the patient watch is different from the doctor's and the driver watch. For example, the doctor watch is customized to read, view the medical details. And at the same time, the patient watch cannot do that because basically they can't understand anything. So that's customized. We customize the doctor's, nurses' features, and smartwatch features inside. For the same thing for the driver, the ambulance drivers. So basically, the ambulance driver, they don't need to know about the medical record of the patient. They just need the location so they can bring the patient from his location.
Okay, just Ali said that we will have in future maybe new things for the user. User need more things about just like
email communication with the watch, like a Siri.
So inside the interface they can use customize for feature.
Okay, the first one, the transaction response time. How do you, where in your deployment diagram or in your diagram that solve that particular issue?
It's actually from the smart microchip to smartwatch, and until it's sent to the hospital emergency unit. The transaction is actually the sending the notification to the hospital emergency unit.
But how do you guarantee that your transaction completes in less than 5 seconds?
As we use the component-based things using Wi-Fi, by providing the Wi-Fi, high-speed Wi-Fi, and as you use the component.
Because you're using a public Wi-Fi, right? Which tend to be congested because lots of people will be connected to that particular Wi-Fi. So you'll be highly congested. How do you ensure that your transaction completes within 5 seconds and there's no timeout or exception?
Well, we're assuming hypothetically, since it's about the future, so we believe that the internet in the future will be like at least 100 times faster than the internet like these days. So yeah, I think like we at like the current technology we have, since we done the test. So from the test, we can assume that we can say that it's 5 seconds for the transactions, and that's also related to the availability of our system.
They say your Wi-Fi is fast, and then but you have a problem in your server. So how do you deploy your server? Is it in multi-location, or is it in just one location, or is it a multiple server?
It's multi-location. The server basically is in
Is
multi-location.
it shown anywhere in your design?
I think in the conceptual design, we mentioned about the cloud in general, but the server in general. But it means it's basically like, because in case of emergencies, there are a lot of hospitals like around the area. So there's also one of the thing that this smartwatch is gonna contact with the nearest hospital to the patient. So that's based on the location of the cloud. For example, if the server between the patient and then the hospital, like they're like the closest destination, then that's the trigger. It's gonna trigger the hospital they're gonna send the notification to. So basically, it's not sending notification to the whole hospitals in, let's say, Kuala Lumpur or like in Malaysia. It's specifically to the nearest hospital.
How does the hospital receive the notification? Is there any installed application or system in the hospital itself?
Basically, yes. As we mentioned, the doctors and nurses, they have smartwatches with customized functionalities that can get or like receive the notification from the patient and take like a medical action against after they review their medical history. Because basically, once they identify the person, his information, his medical records is going to be all popped up in their watches, and according to that, they will know that how the treatment or whether like the patient wants like an operation immediately, or it depends on the patient's case.
So information is stored inside the smartwatch or in the cloud?
In the cloud. It gets recorded. For example, we have the smartwatch can record, measure the every blood-related tests. For example, cholesterol level, blood sugar, and it will be stored in the cloud. And at the same time, the smartwatch can also monitor the blood pressure, monitor the blood pressure, the heartbeat as well, and those all stored in the cloud. So that's how they know.
So the doctors in the hospital is retrieving data from the smartwatch or the cloud?
From the cloud.
Okay.
Yeah.
So far, I don't think it's suitable to say that everything that you do going to be in the future, because this project is for today,
Yeah.
for this semester.
But it's
So
for.
everything when you talk about these requirements and you're referring to the future,
Mhm.
therefore this is not. Maybe do you think that it's not relevant for this today now? Is your marks not relevant today? For better, I'll give you marks in the future.
No, it is, but let's say in this location, I don't think it's possible. Of course, there are some locations around the world that have like
You
Wi-Fi.
have to, if it's not possible, it's not feasible. If it's not feasible, the project is not feasible to be conducted.
I mean,
So
it
are you
is
saying that if
possible.
a project is not feasible to be conducted, it should be discarded?
Yeah, I think it is possible to.
If it is possible, you should find what is the feasibilities of this project to be conducted, technically and non-technically. Correct? Okay. So if you think that you agree on that, it is possible to be conducted. Then talking about the time just now we mentioned. Okay.
Mhm.
So we're not talking about the future internet connectivity. We're talking now. So how it is possible to be to achieve that in the public cloud instead of referring to the future.
Okay, in the current, for example, it's also one of the questions we like popped up, like where we're doing our discussion. For example, let's say if we assume that okay, we can work on this project now. How can the patient, like when he goes outside, there is no Wi-Fi, right? I mean, we assume that the Wi-Fi can cover the whole city. So instead, we're gonna use 4G to keep the smartwatch going instead of the Wi-Fi. That's if we. So yeah, that's basically the solution. So using the current, Wi-Fi internet technology to keep the watch and the microchip running.
Okay, my last question. Why don't you? There should be something like I assume that EMED in the hospital side, right? EMED application and the hospital side. EMED should be application should be your system should be in hospital, right? Also in
Yeah. There is a system.
Okay, then there will be like a nurse and doctors. Okay, you are saying that they are going to wear a watch, right?
Yes.
So, but at the same time, there must be the software system inside the hospital, EMED software system.
Yeah.
So why can't I get those prototype? Why can't I get the demo for that?
I think we forgot to mention it, but you can see it's right here. This is HEU, refers to the hospital emergency unit. So basically, all the information is being received by the hospital emergency unit, and it will be displayed to the doctors relevant to take an immediate medical
Yeah,
action.
so when you're talking about displaying to this hospital staff like doctors and nurses, right? So where actually this is demo?
I think we mentioned that in the
I mean the demo.
in the demo.
Somewhere along the line, there must be videos of the systems, right? Instead of demo the video, if you okay, you understand the scenario.
But as is from the component diagram, it's the interface right here for the doctors and nurses. It's what it's gonna send, get the notification, view medical record, update medical records. Of course, that's after, if for example they did an operation on the patient. So all the details, like whatever records, the current one will be updated again to the server. So for future references, if the patient, let's say, come again to another emergency case, so they will know that this patient had for example an emergency operation 2 months ago. So that's updates. And also, of course, it has to view. This is the reason why we do personal identification inside is because sometimes, if the patient is outside and he doesn't have a wallet and the accidents basically just, tore some of his body parts apart. So and when they bring him to the hospital, they don't know who this guy is and what's actually from or what is he suffering from. So that's why the personal identification here can show to the doctor they can also contact the family as well. That's plus the notification will be sent to the family. So that's why the personal identification.
So you are saying that everything the doctors can have to notify through the watch. Everything has to be done through the watch. Notifying.
Yes.
Doctors is notifying. So which nurses have to do everything on the watch. Are you saying that?
At first thing, from the server club, we
But
send
when
the
I
data.
give the instruction to the system, are you saying that everything that I have to done through my watch, like I contact the relative or whatsoever, that I have to do the stimulus or the instruction through my watch?
Basically, the relative is connected. It will done by the hospital emergency unit. So hospital emergency unit, there is a different interface for the different. Actually, it's not inside the system. We didn't show it, but there is a hospital emergency unit. Just like the phone call for now what happened is any emergency event they use the phone. So there is a system, there is an interface, there is a EC for that one. So emergency unit know that this is the emergency cases, so they can send the notification to the relatives. Not the doctor cannot send the notification to the relatives.
So basically, doctor, staff, just receive message.
Yeah, just receive message and GPS location.
Basically, eliminate the existence of phones. So we don't need phones to contact hospital relatives anymore, since everything will be done automatically from the smartwatch.
Okay, since there are so many doctors, so many nurses, so how do they ensure that they are calling the right doctors? Where's your rules?
Basically, the rules will be all inside the hospital. The HEU, the Hospital Emergency Unit. So once they get all the information,
HU belongs to you.
no, to the hospital.
So how do your system
Uh-huh.
link it to the HEU?
Using the cloud.
Go back to your use case diagrams. Is HEU part of your external system?
We didn't mention the HEU, but we mentioned the doctors, nurses instead.
So HEU is a crucial part of integrated your system, right?
Yes.
But it's not that, is it?
It is actually, it's in the conceptual design right here. So we showed it in the conceptual
But it's
design.
not in your design,
It's not in the use case diagram.
in the overall design. I mean the architectural design. So this is one of the your conceptual, but you did not capture in your specific architectural designs. You don't.
Yeah, but we assume that it's the doctors, nurses are extended from the HEU. Means like the HEU is the part, and the doctors, nurses. The HEU is included or like extended from the nurse and doctors, because this part is all related to the hospitals. So hospitals including doctors, nurses as well. It's like a generalization.
Okay, one last question.
Can you go back to the class diagram again? Just now you said microchip is communicating to the, this one, the class diagram. This is this.
The
yeah.
component, yeah.
You said the microchip is connecting to the smartwatch.
Yeah. Using the NFR.
Using the NFR.
Yes.
How does this microchip is talking to the cloud server?
Yeah. It's actually.
How does this cloud server is talking to the microchip? It's user.
Yeah. For like extra information, for example, here we didn't mention that the reason why the microchip need to be connected to the smartwatch for the blood-related tests. For example, we took the cholesterol level, blood sugar. So once
the line used there from
yeah.
the cloud server to microchip.
So between the microchip and the cloud server, there is a line, right?
And that line used there. This for
Why?
what?
Yes. This is like an interface between the cloud and the smartwatch.
No, the
Smartwatch and
smartwatch.
microchip, that's
The
microchip.
microchip.
A microchip.
Why there is a communication between the microchip and the cloud server?
Why is there a connection between the microchip and the cloud server?
Yeah.
Basically, for the records, the medical records. So because the medical records will be stored inside these microchip. Microchip is work like a teeny tiny pin driver. So all the medical records of the patient is stored inside the microchip, as well as
Medical records is stored inside microchip.
yeah,
That's the first.
yeah, as well as the personal identification. So basically everything related to the patient, from like name, day, birth date, all the personal information also be stored inside the microchip. Yeah, the NFR, like we didn't mention here, the reason of the NFR is because we wanted to send the data of the blood-related tests to the smartwatch, so it can be displayed, like cholesterol level and blood sugar. These as two examples.